Hello, I'm Janis Lange and my research is about renewable energy resource mapping and energy system modeling. In this module, I will tell you about the assessment of renewable energy potentials. Let's start again with the amount of sunlight hitting the Earth's surface. You can see the day-night cycle, but also the sheer amount of solar energy reaching our planet every day. You might wonder, if there is so much renewable energy coming at us all the time, why is the energy transition still such a challenge? One of the reasons is that renewables cannot be implemented at any location. Some sites are more favorable than others, and again others might not be suitable at all. In today's video, you will learn how renewable energy resources can be defined and distinguished, how they are mapped, and what you need to consider when encountering resource assessments in media. Renewable energy resources are usually assessed as potentials. Potentials reflect the amount of power or energy within an area under certain restrictions. The area depends on the researcher's interest and can span over a city, province, country, continent, or even the entire world. There are different types of potentials, which differ by the restrictions that are imposed on them. The most common distinction is between resource potential, technical potential, economic potential, and market potential. In this video, we will only cover the first three potentials in detail. Let's first take a look at the resource potential. The resource potential reflects the energy content of the renewable resource before it is converted to electricity. This includes solar irradiation, kinetic energy of the wind, and the heat stored inside the Earth. The resource potential is a rather theoretical concept. It does not tell much about how much electricity demand can be covered and where interesting sites are. For these aspects, you need the technical potential, which reflects the energy or capacity of renewables after the conversion to electricity and the exclusion of unsuitable land. The name-giving technical restrictions may include losses from power conversion, storage, transmission and distribution, as well as the downtime of the plant due to maintenance or malfunctions. The technical potential also considers non-technical restrictions for plant site selection. For example, technically you could install a wind turbine on a city square, but then there might be resistance from residents affected by the turbine. Other commonly used site selection criteria are nature conservation zones and wetlands. Keep in mind, though, that both technical and non-technical restrictions depend on the assessed technology. A lot of land must be made available for a fully renewable energy system. As you can see below, solar PV and onshore wind can be quite land use intensive. Finding the right sites for power plants can be challenging, as they can affect the economic, social and environmental value of land. Moreover, some regions might not have enough land for large solar or onshore wind parks to begin with, like small island developing states. This is why offshore energies are important for a successful energy transition, as their land impact is limited and island countries can make use of their surrounding marine areas. The technical potential already gives a good understanding of how much electricity could be covered with renewables at a given location. However, it does not yet tell whether these renewable power plants are economically attractive. The economic potential addresses this and reflects the part of the technical potential for which benefits exceed costs. In the last videos, you already learned about the LCOE, which reflects the tariff needed to recover all costs of a renewable power plant. If the LCOE is equal to or lower than the tariff that the plant operator actually receives, then the plant operates at a profit and contains an economic potential. You may see that there are a lot of moving parts when assessing renewable energy potentials. The key message of this module is that potentials strongly depend on the underlying assumptions and methods, so stay critical when you encounter them in media. For example, you may ask yourself the following questions. Do the authors clearly state type or potential being discussed? Are the methods transparent and applied consistently? Are the assumptions aligned with the state-of-the-art and expected developments? Are the potentials put into perspective? For example, how much electricity demand can be met, or how much land area would be required? To wrap this video up, let's look at our overview table. You can see that solar PV and wind power have the highest global technical potential. CSP, geothermal and hydro, on the other hand, have a limited potential for various reasons. While solar PV can convert both direct and diffuse sunlight, CSP can only harness direct sunlight, which is only readily available in certain parts of the world. For geothermal electricity production, sufficient thermal resources are required, which are mostly situated in the USA and countries along the Ring of Fire, like Indonesia. For hydropower, strict geographic conditions must be met, like a sufficient difference in altitude or flow of river. However, this assessment right now is just a snapshot of the current state of the art, so technological developments might provide further potentials in the future.